Okay. Hello class. Next is potentiometer. Very important topic. Current electricity. Chapter 2. Class 12th. Potentiometer is a device which is used to compare the EMF and the internal resistance of cell. It based on the principle that constant current is flowing through a uniform cross-sectional wire, then the potential across any length of the wire is proportional to that length. Means potential voltage is proportional to the length of the wire across any portion, but the condition is current is constant and the wire is of uniform cross-sectional area. This is the principle of potentiometer. If we consider, according to Ohm's law, V is equal to IR, R is equal to rho L upon A. Resistivity, that is the characteristics of material for which the wire is made, that will be the part of potentiometer. Length, area of cross section, and V is rho L AI. And what is the condition? Condition is current should be constant, area of cross section should be constant, and this is the constant for the given material. So what we got, V is equal to constant L, or V is proportional to L. This is the principle of the potentiometer. For the constant current and for uniform cross-sectional area, potential drop, potential difference is proportional to the length of a wire. And what is the construction for this? In this, we have the 400 centimeter wire. That is in 4 segment, 100 centimeter. Then how we draw this? This one for segment. Now these two are the terminals A and B of the potentiometer, and this is on wooden board. 0 to 100, 100 to 200, 200 to 300, 300 to 400 centimeter, 4 segment. And here we have the scale along the wooden table along the wire length. But scale is graduated in two sides, 0 to 100 and again here 0 to 100. Because when the jockeys move over from A to this end, we note the 0 to 100 along this. And when it is along this word, then we use the downward scale, that is towards, opposite to first. Let me say, here we get the null point or balance point, and this is 100, let C is 30. So what should be the value? 130. And there is a auxiliary circuit also. Auxiliary circuit means driver circuit, which give the current for this whole process. And this circuit, it is consist ammeter, auxiliary battery, rheostat with key, and this part with the key, and this part is connected to B, and this A is connected to part A, and this whole is called, this is rheostat. Rheostat is unknown variable resistance which keep the current constant. Battery, this is the ammeter, that will be ammeter which notes down the current, that is positive, negative. And for verify this, that we have the activity in our practicals also. Here we have voltmeter, that positive, negative, and here we have the jockey. We verify this voltage, particular voltage, that is proportional to the length of that. This is the part of an activity. Now come to the applications. For what purpose this potentiometer is used? As the first application is to measure the EMF of a cell. Cell EMF find out करने. Firstly, we graduate these wires. How we graduate? By using the standard cadmium cell. Standard cadmium cell. That will be have the EMF 1.018 volt. Why are we considering this standard cadmium cell because its EMF remain constant for the long time when it deliver the current. So we considering it standard cadmium cell, and for that we take the cell galvanometer for getting the null point. Here we say E dash. These two must not be same, and the driver battery EMF must be greater than whatever you have to required in this. To see EMF find out करनी है, internal resistance find out करना, compare करना, तो ये तो बड़ा होना चाहिए, otherwise circuit है जड़ा हो proceed नहीं करेगा. Then first of all we set up, give the setup according to this circuit, put the standard cell here whose voltage is 1.018 EMF. Now the jockey is put 203.6 centimeter wire, 6 centimeter point. जिथे 203.6 आंदा उथे jockey असी place कर रहे हैं. In this case, to graduate the wire, first we change the current with the help of this rheostat. Because when we changing the rheostat, we changing the resistance that will be affecting the current. And when this galvanometer shows zero deflection, keep the current at that value. Now it balance the things. And what we got? Potential gradient of the wire. Potential gradient, that is divide by this, and the gradient is 5 into 10 raised to power minus 3 volt per centimeter. This is the potential gradient. Now remove the standard cell with that unknown EMF cell, and now keep the current constant. Now work on the principle of potentiometer. Keep the current constant, move the jockey, slide the jockey over the wire. Note the balancing length. When the galvanometer shows the deflection 0, let it be L. Then how we find the EMF of that cell? This potential gradient, that we say dr or dl, we can say it dl also, dv upon dl, multiply with L, 5 into 10 raised to power minus 3 into L centimeter. That will be volt is the EMF of the unknown cell that we calculated by using this potentiometer. This is the first application. And for the second application, where we have to compare the EMF of two cells. The remaining circuit is the same. This is same auxiliary circuit. Here we use the two cells. The positive terminal E1, E2 connected to end A, and the negative terminal of the both cells, they are connected to two-way key. Two-way key. This is the one-way key like this. But here we have the two-way key also. Center is common to both. And this common point is connected with galvanometer, with the resistance box and the jockey. Now keep the setting as in the circuit. Now firstly put the plug in this and keep E1 in the circuit. Keep the current constant, move the jockey, note the balancing length. That for E1, this balancing length is L1 and I is the current in the circuit. Here we have the term X, where X is called resistance per unit length of the wire. Resistance per unit length of the wire. Then this E1 is XL1I. This is the first. Now remove the plug from this and put the plug here to put the E2 in the circuit and note its balancing length. Again, balancing length is where when the galvanometer shows the zero deflection. Then E2 XL2I. And when we divide it, what we got? E1 upon E2 is equal to L1 upon L2, and here we compare the EMF of two cells. And this is also, we have the practical in our syllabus, how the potentiometer is used to compare the EMF of two cells. And then the last one, where we calculate the internal resistance of the cell. And for that, again we change this setup. Other circuit remains same. Now we have a cell whose internal resistance is calculated. Here we have the galvanometer, then again the resistance box, and here. Now here we have one more resistance box, that is called the shunt, and the key K2, this one. This is the EMF E, then we put here E dash. Now what is this shunt? This is not a special type of resistance. This is a resistance of small value that is always connected in parallel. Shunt is always connected in a parallel. Okay. First of all, take the apparatus, do the circuit diagrams, do the arrangement according to the circuit diagram. Firstly, keep the key out here. Put the key here to give the current to the circuit. Note the balancing length. That will be balance the EMF of the cell because it is an open circuit. And when the open circuit, the voltage is called EMF. That the balancing length is L1. Again, X is the resistance per unit length, L1I. Now, put the plug in this. Take the cell in the circuit and apply the first value here. Any value, suitable value. Let it is a S. Again, find the balancing length. That will be balance the terminal voltage or potential difference XL2I. Divide this, we have L2 upon L1. In the last segment, we have the relation for the internal resistance R, that is E upon V minus 1 into R. Then by using this setup, we compare this and we find this L1, L2. L1, L2 minus 1. What should we put here? This shunt value. Then how we calculate the internal resistance? L2 into S. So this is the potentiometer setup which is used to measure the EMF of unknown cell, compare the EMF of two cells and to find the internal resistance of the cell. So this is for the theory part of this. Let's discuss one question for the numerical question for the Kirchhoff law. How we calculate the values by using the Kirchhoff law. One example for that. Then so that the things must become clear to all of you. How we calculate, how we use the Kirchhoff rule over there. Here we have a circuit diagram, that is network, this, and this is the resistance. Here A, B, C, D, E. This is R. This is E1. Internal resistance R1. E2. Internal resistance R2. This is the current I1. This is the current I2. And here we can say the current I3. Okay. And the value is 6 volt. And this value is 4 volt. And this value is 2 ohm. And this value is 3 ohm. And this value is 5 ohm. Now we have to calculate these currents I1, I2, I3. We have the two rules in Kirchhoff law. First is at the junction point. This is the junction point, F point, where these two currents are towards the junction and away from the junction. So at F point, I1, I2 minus I3 equal to 0. Means I1, I2 is equal to I3. This is the junction rule that towards wale plus or a minus. Now we are considering the loop rule. Consider the loop anti-clockwise. Consider this loop anti-clockwise in A, F, C, B, A. First we considering the EMF. Battery always give the current from positive terminal to negative terminal. Always positive to निकलता current, negative च enter करना show करना. If it is in anti-clockwise, जे delivering anti-clockwise है, the EMF positive, और जे clockwise है, the EMF negative. We considering the loop anti-clockwise. So what about this battery? Delivering the current anti-clockwise. So it is positive. And this delivering the current clockwise. This is not considering. सिर्फ आ वाली loop consider करनी है. Minus E2. Then this current, this resistance in our direction, this is in opposite direction. So I1 R1, I2 R2. So this is 6 minus 4. This is 2I1 and this is minus 3I2. So 2I1 minus 3I2 equation 1. Now come to the second loop, this loop. In F, E, D, C, F. Now this is the only one battery in this loop and this is delivering the current in anti-clockwise. So it is positive and this is again anti-clockwise. So they both current are positive. 3I2 plus 5I3. Then E2 is 4. 3I2 plus 5. What about this I3? I1 plus I2. Then we have 3I2 plus 5I1 plus 5I2. What we got? The second equation. 4 is 5 plus 3, 8. That is 5I1, 5 plus 3. That is 8I2. Equation number 2. Now we have the two equations. Okay, now we have the two equations. That is R2 is equal to 3 ohm. Then we have the two equations. This one 2I1 minus 3I2, 4 3I2, this 5I1 plus 8I2. Now we have to solving these two equations. Multiply equation 1 with 4. 8, 4 to the 8, 8I1, I1. No, this is not by this. We have to calculate this two equations by finding this value. So multiply this by 5 and this by 2. Then we have 10I1, 15I2 and this is 8, 10I1 plus 16I2, then minus this, cancel 2 and what we get? 31I2 and I2 become 2 upon 31 ampere. Minus 2 upon, that will be minus 2 upon 31 ampere. This is the I2. Now by using this I2 in any one equation, in equation 1 or in equation 2, we get the I1. By calculating it simply, we get the I1, that will be 28 by 31 ampere. That will be 28 by 31 ampere. And what is the I3? I1 plus I2 and the I3. By using these two values, we have the values that is 26 by 31 ampere. So we're finding I1, I2, I3. That is the question of Kirchhoff law, how the Kirchhoff law is used to find the values. So keep practicing these values by taking the different networks. Okay, thank you.